Okay, we're in section 82 now. Again, read the contents, try to make sense out of it, the examples, which I'll walk you through, and then get busy with the exercises. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells's Advanced Course in Algebra, which dates back to 1904. At present, this PDF document is only being made available to the Prison Mathematics Project participants. I do plan to publish this in the future, and as I do that, you may be interested in getting a copy of it. And if you are, what I recommend do is reach out to me. My name is Bannon, and my email address is also Bannon. That's B as in boy, the @ symbol, NNON.US. Okay, so what are you going to do? You're going to read through it. Right, it's very short. You read through it. All right. My intent here is to, go through it. And as I'm doing it over here, certainly I'm going to explain my reasoning skills. They're certainly not different than Wells, but they may look different. But it says find 3 numbers in a geometric progression. So what do I know? I know there's 3 numbers. I'll write this down. 1, 2, 3. Now, what would they look like? I don't know what they are yet, but I'm going to say 1 would be x. Right, that's the first term. The next one's going to be x times r, or xr. And the next one's going to be, xr times r, which is xr squared. Now, what do they tell me? They want me to find these 3 terms such that their sum is 14. So I'll write that down for you. X plus xr plus xr squared is 14. All right, what's the next thing to say? And the sum of their squares. Well, I'm going to write their squares down now. X squared plus x squared r squared plus x squared r4 is equal to 84. All right, so what I'm going to claim over here is certainly, as you're working through this over here, certainly we have an answer key down over here. And certainly, as you're looking at an answer key, I want to get to the end of it. But, I want to point out it's really important, they're looking for 3 things. And they're geometric in nature, and there's 3 terms of that geometric sequence. And you know what a geometric sequence is at this point. So really what I'm trying to find the x and the r. Right? I'm trying to find them. So I just want to make sure you understand this stuff's written down for you. And that's the easy part. Right? So I'm going to say most students, ability to read that would be able to get through that. Now, what I want to do is I want to do something which may seem outrageously difficult to do. I'm looking at that, and I got to solve for x and r. And that does look tough for me. All right? So I got x in it, I got r in it. R is a 4th degree. X, I got 2nd degree x's in it. It just looks tough. So I'm going to try to reduce the complexity of it by doing a division. I'm going to write the division down for you. And I'll actually perform the division. So it's x squared plus x squared r squared plus x squared r4, and I'm going to divide by x plus xr plus xr squared. I hope you realize that these are non-zero. Like x can't be 0 and r can't be 0. I wouldn't get those numbers. So what's this going to be? 84 over 14. Well, you know what? I think the 84 over 14 looks pretty simple to me to do, and I'll do that for you. That's going to be 42 over 7, and that's equal to number 6. What's more challenging for me is this division problem. But before I do it, though, I'm going to factor an x out. And what do you get? X plus x r squared plus x r 4 is still equals 6. And then we had a bottom x 1 plus r squared. All right, what happens nice here? Well, the x's cancel. Again, they're non-zero. They cancel. I don't know what it is, though, but I know they cancel off. I got to do my division now because I can't see anything else to do. And I'm hoping the division works out really nicely. So I'm going to put down 1 plus r squared is being divided into, and I'm really hoping for something nice to happen. If not, I got to rethink what I'm doing. Well, what do you get there? You just get x, right? Let's write that down. You get x plus xr plus xr squared. Well, immediately I notice when I subtract those two that some things are disappearing. I want to point out this would disappear. This would disappear when I'm subtracting. Let me write this down for you. And what do you get? I got to be careful here, right? So minus xr, all right? And then what are you going to get? Let me see if I did this right. Yeah, I did okay. Plus xr to the fourth. Now I got to repeat. What am I going to get? Minus xr now. Let's see what you get. Again, I'm hoping it's going to work out nice. Minus xr minus xr squared. And then what are you going to get? Minus, I got to be careful here, xr cubed. Well, let's see. I certainly know some things are disappearing over here. It's maybe not be shaping up what I want, but I'll keep plowing forward. And you should too. You should not give up so easily. So I'm going to say, well, it's not that bad. It looks like x r squared plus x r cubed plus x r 4. Well, I'm matching game again. What do you get over here? Plus x r squared. Let's multiply it. What do you get? xr squared. Let's see, plus xr cubed plus xr to the fourth. Lo and behold, we get a 0. Now, granted, let me write this down for you. What am I getting now? I'm getting this. I still have two unknowns, though. But I have a new equation that might be useful. I don't know. All right? So I'm going to look at this. I want to point out, I'm looking at this. I just obtained this. I want to go back over here, and I'm going to look at something that looks something like that. And I'm going to say it looks sort of like this guy over here. I'm going to put that down right next to it. And that was x plus xr plus xr squared. All right? Now I'm seeing these two over here, and I'm wondering, could I subtract those two? I think I can. And the reason I want to subtract them is a bunch of terms will disappear. Like if I subtract these, oops, sorry about that. I didn't mean to do that. If I subtract this, these will disappear, and these will disappear. All right, let me see if I can do that. Let's see if we can do that. And I'm going to take this here. Whoops. I'm going to be taking this here and subtracting this away. Well, 14 minus 6 is 8. And then what do you get? Everything disappears. Those two middle terms, I'd get 2 xr. That's another equation I can use. Let me tell you what I mean by that. I'm looking at this, and I'm going to use it. And I said, how would you use it? I guess I got to manipulate it. And I'm going to try something. I'm going to try to solve this thing for x. And what do you get? X would equal, well, that would be 4 then. I'm dividing by 2, and I divide by r. Now, what am I going to do now? I'm going to substitute. Someone said, where are you going to substitute? Wherever you like. And I'm going to choose this one over here. Yeah, this for a lot of students, it says, will it ever end? It ends when it stops. So x is 4 over r. Write this down for you. We'll look at the key later. Minus 4 over r times r plus x is 4 over r times r squared equals 6. Well, I'm going to simplify that. And what do you get? You would get 4 over r minus 4 plus 4r is equal to 6. I'm going to multiply both sides by r to get rid of the fraction. And what do you get? You would get 4 minus 4r plus 4r squared. Make sure I copied this right. Yeah, I think I did. Equals 6r. Well, I'm going to write it as a quadratic now. So it's going to be 4r squared. It is quadratic. I mean, write it in standard form. Minus 10r plus 4 equals 0. I'm kind of running out of room. I'm going to move this up. I'm going to divide through by 2. You would get 2r squared minus 5r plus 2 equals 0. I'm going to make some attempt to factor that. Now I'm going to say 2r and r. We're getting close to a success story here. I'm going to say minus 2 minus 1. Let's see if that works. Because 2r squared minus 4 minus 1 is minus 5. Works like a charm. So now I know r is 2 or r is a half. Let me go back up here. I'll write this down. Now I know r is 2 or r is a half. Now, I'm not out of the woods yet. So what I want to do, I want to see if I can figure out x then. And what's x? X would be 4 over r. All right. If r is 2, what do you get for x? X would be 2. Let's see. If x is 4 over r, what would you get? X would be what? 8. So I'm going to write this sequence down. And so where's the sequence coming from? Right over here. So let's take a look. X is 2. And let's see, r is 2, right? So you get 4 here. And then what would you get? Well, let's see. That would be 8, right? That's this sequence here. Let's do this one. 8. And what? R is a half, right? So that's going to be 4. And again, r is a half, so it would be 2. Get this sequence. All right, what was our question? Find 3 numbers. I found them. What are the 3 numbers? 2, 4, 8. Look at the key right over here. All right, 2, 4, 8. Okay? We did okay. Was it work? Of course it was work. All right? Where are we going now? Well, we're hoping you kind of followed along there. Yes, things can get tough. You need to get the exercises done. That's where a lot of your work is going to take place. And again, for the most part, basically it's, working through problems that are geometric in nature. And there's going to be some things to solve, all right? So I'm going to say, for the most part, really not that bad. You got number 1, number 2. I put work down and answers for you. This is something that Wells does not do. 4, 5. I'm sure Wells had a book with an answer key, though. That is nowhere to be found. What I mean by an answer key, not just the numbers, the end, but the work in between. He must have had it. They employed people to do it. All right, I'm sure of it. Might have been students who were very lowly paid to do that. But I want to be honest with you, though, the students that were working on that probably it paid off for them. They probably learned the subject much better than other students, and they got an in at MIT. What I mean by that is if they're working with Wells at MIT, it's a good thing. All right? What does that mean? Their careers progressed, certainly. 15. Looks like a lot of questions, doesn't it? And again, I'm glad for that. And the reason for that, it allows a lot of opportunity. And I put a lot of work down for you. Yeah, it took me time to get through it too. Don't think this stuff is easy for me to do either. It takes time and effort. A lot of time and effort. All right? Then you get to this related stage code over here. And again, I can't say enough times a computer algebra system, or CAS for short. It's open source, meaning free software. That's the website. Download it. Interactive web-based application. By the way, I want to point out about the free part. I guess the father of Sage, he's a college professor, and he develops something. He develops a product that's useful for his point. But a lot of people see it as being a good product, and a lot of people start working on it. Not just the professor, but a lot of other people. And this is so true about good software that's being made available to a community. A lot of people work on it. So although it appears to be free, to use, what happens is they're trying to get people involved in working on it. All right. What is working on it? Writing books about it, promoting it, improving the code base, yada, yada, yada. And it's really good software. All right. But anyway, I say there's some code over here you may want to look at, but that's not my intent here. My intent is, maybe not to get you to code, but to think about it. It's part of your futures. But my goal here is to, to get you to think about how to do these things using paper and pencil. So if you're looking over my work and say, I think there's an error, please reach out to me. Again, my email address is Bannon, that's B as in boy, the @ symbol, NNON.US. I will appreciate it, and every reader of this document will appreciate if you point out errors. Thank you for paying attention.